If you want to guarantee your application will collapse under pressure, give your server a perfect memory. Most systems start by relying on vertical scaling. You take a single, powerful machine and keep upgrading the RAM and the CPU to handle more work. In this setup, one machine handles everything, managing the logic, talking to the database, and keeping user sessions right inside its own internal memory. But hardware eventually hits a ceiling. When your user count jumps from 100 to 100,000, that single processor runs out of capacity. To keep growing, you have to move to horizontal scaling, which involves adding multiple servers to share the load. Distributing traffic this way introduces a hidden architectural trap if those individual servers still try to remember the users they interact with. When you add machines without changing how they process data, the system becomes more complex without becoming more capable. This is a stateful system. The server remembers user context by holding open sessions in its internal memory. Because it holds this data, you're tethered to it. Every request must return to that exact node. If that server crashes, every session evaporates instantly. This is a common trap in AI-assisted development. AI tools often generate code that stores global variables and session data directly in the server's memory, because it's the simplest way to get a single machine working. The result is a broken user experience. If your next request hits a different server that has no memory of you, the system assumes you're a stranger and prompts you to log in again. These stateful servers make growth difficult because every new user creates a fragile, unbreakable link to a single point of failure. To solve this, you have to move to a stateless architecture, where servers are intentionally designed to have no memory of past interactions. In this model, the user arrives with their own identification token. The server processes the specific task, provides the response, and instantly forgets the user exists. Here is the structural benefit. With no unique memory, any network node handles any request. When traffic spikes, you spin up new machines. The load balancer distributes packets evenly across the entire array, since no user is tied to one box. Stripping memory from the server layer allows the application to duplicate its processing power as fast as the traffic demands. But if the servers are amnesic, how does the application actually track who you are and what you're doing? The data hasn't been deleted. It has simply been decoupled from the server and moved to a shared environment. This is the centralized source of truth, a dedicated database or high-speed cache that sits safely outside the server array. When a request arrives, the stateless server queries the shared database, verifies the user, completes the action, and then empties its own cache. Separating the processing power from data storage allows a system to survive massive traffic surges that would otherwise cause a crash. As your application grows, you must audit your code to ensure no hidden memory loops are sneaking into the server layer, especially when you use AI-generated logic. The formula for scale is consistent: stateless servers plus external state. Designing clean system boundaries keeps an application stable under pressure, regardless of the size or cost of the hardware. To build a system that never forgets its millions of users, you have to teach your servers to forget everything. This was day 15 of learning system design. This single choice in memory architecture dictates whether an app thrives during growth or suffers a total collapse.